Hi, everyone. This is Jeff Williams, CTO at Contrast Security, and today I'm joined by Ed Amoroso. He's a legend in the security community, and he's helping us at Contrast. He's shown some interest, and so we're going to give him a demo today, and we're going to try and make this interactive. So, Ed, how are you doing today?
I'm doing great, Jeff. How are you doing?
I'm doing fine. All right.
Good.
So, why don't we just jump right into this? As you know, Contrast is an application security product. We try to help companies revolutionize their application security programs across, their whole portfolio and their development process, as well as their production protection against attacks. So we're going to kind of talk about the whole range of things today. So first, I just want to start by showing our Contrast dashboard here. So I'm browsed to our SaaS offering. We do offer an on-prem solution as well, but you can see here's our SaaS dashboard, and I'm currently monitoring 17 different applications across 37 different servers. Now that's actually important because every application lives in multiple different environments. It's in development, it's in CI/CD, it's in test, and it's also in production. So if you want to really understand security, you need to be looking at it across those different environments. So we'll drill down into that a little more as we go. You can see we've got some statistics about libraries and remediation rates for various levels of vulnerabilities. But probably most importantly, we've got a window here into what our vulnerability status looks like across our whole portfolio and what our attack status looks like. And there's really no other product that looks at both vulnerabilities and attacks with the same technology. Would you say that's true? I mean, you know every security product on the market.
No, I think that's a nice feature. The apps that you're looking at, I'm guessing increasingly, do you find your customers really are moving to SaaS? If you and I were on the phone like 10 years ago, it would be all on-prem. But is it really accelerating out into cloud?
Oh, definitely. Even, I spent 15 years consulting with some of the largest financials, and even the most stoic, reserved companies in the financial space, even they are doing cloud initiatives where they're moving various parts of their infrastructure into the cloud. It's really quite amazing.
Makes the vulnerabilities component super useful because most of the vulnerabilities are going to originate externally, right?
Well, I think what's interesting is, as we shift both to cloud and to DevOps, the legacy approach to application security with, sort of big vulnerability analysis, big security review, maybe a WAF, like those things just don't work in that new environment. So we're seeing a lot of demand for what we're doing.
Yep, sounds good. They all take too long, right?
Yeah, they're too long. And most importantly, they require human expertise in the loop. Like you can't run some of those tools without human experts in AppSec, and you just can't find those people. And they're also too slow. So yeah,
that makes sense.
So let's take a look at how this works. So the first thing, why don't we go through the process of adding a new application so you can see what it's like bringing another application into the fold here. So this works almost exactly like a New Relic or an App Dynamics in the performance space. We just work for security. So you can choose your language here. We support Java, .NET, Node.js, Ruby, and Python is coming out soon. So I'll just do a Java example here because that's kind of my wheelhouse. So you download our agent. It's a very small jar file. It's pure Java. And then all you have to do is add that to your application environment. So here we add the Java agent flag to the way we launch Java, just like any other Java VM argument. And then that's it. We work in all the different app servers with all the different frameworks that are out there. And once you restart your application with this Java agent, then we're there. We're starting to work immediately, and we'll give you both assessment and protection right away. So the first thing that you'll notice is that Contrast automatically profiles all the applications that are running on that new server. So often it's one app, but frequently it's 5 or 10 different applications running on an application server. We investigate all of those and report them back to the Contrast team server, which we're looking at here. So just a reminder here, Contrast has two parts. There's the agent that runs as part of your applications or APIs. And then there's the Contrast team server where all that data gets pulled together and you get a unified view of AppSec. So here you can see a list of all the applications that I'm looking at, and I've got some that are pretty good and some that have a number of vulnerabilities. And the other thing that we do at this stage is we also profile all of the open source code that's used across any of those platforms. And with the Equifax breach just right in the news, I think this is really an important time for this capability. Everyone should really have a good understanding of exactly what code they're running, exactly what versions of things they're running, and exactly what servers it's running on. If
Hey,
Equifax,
Jeff, those grades that you're showing for the different jars and so on, where do they come from? Is that the result of that profiling and investigation that you're doing?
Yeah, we grade both the applications based on their risk score. So we look at sort of, if you can imagine sort of summing up all of the risks and library problems in all those libraries. We give you an overall application grade. And then for this screen, we actually grade the individual libraries. So here you can see, there's a couple of libraries here that are quite good because they're using the latest version. But then this access.jar here has two known vulnerabilities, two CVEs against it. And so you can see that gets a bad grade. And we grade both on how out of date it is. You can see here's an example of a library that's, many years, at 12 years out of date, as well as known vulnerabilities. So we're giving you kind of both views of it.
Looks like the presence of a CVE implies bad grade in each case. Is that generally right?
Yeah, for sure.
Yeah,
And
that makes
we
sense.
take into account the CVSS score. So, some of these are serious, some of these are less serious. So, we want people to prioritize the risks that they work on. Because so many folks just get a PDF report and they just try to work on everything, and that doesn't really work very well.
That makes sense.
One thing that's kind of unique about what we do here, and Gartner would call this software composition analysis, is that we not only look at the vulnerabilities and how out of date things are, but we also look at how much of the library is actually used. So here you can see in this access.jar, it's actually using a pretty healthy chunk of this library, whereas some of these others were using 0 classes out of that library. And what's fascinating—
Is that a static analysis or a runtime to determine percent use? That's interesting.
That's a runtime analysis. So we're actually watching these libraries get invoked, and we keep track of how much of that library is actually used. And what's fascinating is that 72% of libraries in the typical application are never invoked at all. They're only there for like dependency or compile time reasons, and they don't get called. So we see a lot of folks running around trying to upgrade those libraries because some static tool reported that they're got a vulnerability in them, but frankly they're never used by that application and don't represent significant risk.
If some of those unused components are things like exception handlers or whatever, they're probably not a bad idea that they're not invoked, right? They'd be invoked in case of a real serious problem. So is that sort of accounted for? Like, do you do sort of a weighting? Because I'm sure you're right. Like, if there's a lot of dead components here, then yeah, I mean, if it's unused, that's bad. But sometimes it's good that it's unused. Am I reading that right?
Well, that's possible, but for the most part, these libraries are not used because there's no reason to call them. Many developers use a whole library for one function or one small piece of capability. And then that one library may bring in a dozen other libraries as subdependencies. And so, if you're not using the part of that library that causes the dependency to be loaded, there's really no risk from any of that.
Yeah, that's a very cool feature, and that looks very useful.
It's important to understand the code that you have and the versions and so on. Ultimately, our goal is to help organizations really understand their whole application portfolio, their whole inventory. And I know most companies struggle with this. It's a difficult job. If people are, different groups are standing up applications here and there, sort of the first step of security is to get your arms around what it is you're trying to secure. And it's a big challenge. So many organizations kind of scan for applications to look for, any rogue applications that are started up. We take a very different approach. We say, hey, you standardize on a platform like an app server platform and include contrast in it, and we'll automatically tell you where all your applications are and exactly what's in them and so on. So it's a little bit of an ask. We ask, hey, you got to add our agent to your standard platforms. But once you do that, the value and the power of having everything real time, everything up to date is incredibly powerful.
Right, makes sense.
Okay. So any other questions on sort of the installation and the architecture of how contrast works?
No, I think that looks really good. Looks like a very simple installation process. And yeah, let's proceed.
Okay. Cool. Yeah, it works the exact same if you want to use this in cloud or containers or wherever the application runs. That's where contrast runs.
Normally, containers introduce some complexity at provisioning time for some tools. I guess this was sort of born in the context of containers and cloud, right?
Yeah, we're very cloudy. If you want to use that term, we're very container friendly because we're just part of the application itself.
Yep,
That's why
good.
our slogan is self-protecting applications, and the idea is that the application is what really needs to be doing the security for itself, and we help it out. So let's take a look at the vulnerability analysis here. So the inventory piece is one big chunk of what we do. The next piece is that we actually analyze each of those applications for vulnerabilities. And I'll be demonstrating with WebGoat here, which is a fairly well-known, deliberately vulnerable application from OWASP. I actually wrote it back in the late 1990s, but it's a good demonstration of what a really vulnerable app looks like. On the other side, contrast doesn't really have limits around scale. We've worked on applications that are well in excess of 20 million lines of custom code. Again, because we're just sort of part of the application.
Just check, would your grade kind of go down with size? Like as something gets bigger, is it likely to have some problems just by the nature of having that many lines of code? Or are you pretty agnostic about size?
Well, some kinds of vulnerabilities scale that way. Like XSS tends to scale with the size of the UI because there's so many more opportunities to put in XSS problems. But other kinds of problems don't. Like if you've got, typically applications have a single encryption capability and either you get it right or you don't. And so those don't scale with the size of the application, really. It depends a little bit. And then the grade does scale with the number of vulnerabilities and their severity. So, larger applications can tend to do a little bit worse.
Yeah.
So I want you to imagine now, instead of having to go through your application inventory one by one and doing a scan and then getting the PDF file with the results in it, I want you to imagine that you had a live dashboard for each of the applications in your whole portfolio, all being updated in real time in parallel. And this is an example of that dashboard for WebGoat. And basically what we're trying to show here is the security of that application across the life cycle. So you can see here, we've calculated a score, an overall score, but we also show you what it looks like in development, in QA, and then also in production. And here you can see, well, there's a lot of vulnerabilities, even in the QA environment, and we're actually being attacked in production. So this is not a good scorecard. That's not what you want to see, is you're vulnerable and you're being attacked. That's a dangerous situation. Now, you might have noticed that we're finding vulnerabilities in QA, and that's not a sign of a healthy project. Really what you want to see is that you're finding and fixing vulnerabilities in development and that the number of vulnerabilities in QA goes down dramatically. If you're trying to use static analysis tools or dynamic scanners, typically you can't get that level of data because it's just so expensive to run those tools and get the results and triage them and compare the results. But Contrast monitors those, all the environments where that application is running to give you data continuously.
Hey, Jeff, in the context of like a typical DevOps, where a group is going through daily and weekly,
Yeah.
the sprints and scrums and so on, how does that map to development, QA, and production? Would like a DevOps would that be embedded in development, or is that kind of touch each of the three here somehow?
Yeah. A little bit depends on how you run your software development practice. We
Hmm.
give you these three buckets that you can put servers into. And typically people put their developers, working in their IDEs, and then maybe their CI/CD server in development. But then in the QA environment, we're looking at more at like test servers and dedicated QA or staging servers for the data to go in there. But you're free to assign those different servers to whatever bucket that you want so that
Hmm.
you can get the data how you like it. We found that, so many tools try to force you to change the way you do software development, like add a gate here, we're going to do a check here, we're going to block this. Contrast doesn't really work that way. We're in the background. So as you'll see, you don't have to uh, attack an application to find vulnerabilities. So we can run in the background and just detect these vulnerabilities while normal development activities are going on. So it's very unintrusive into a typical software development lifecycle.
Got it. Makes sense.
Yeah. So let's take a look here. Let's drill down and take a look at some vulnerabilities. So again, we're looking at WebGoat, and Contrast finds a broad range of vulnerabilities. Here in this list, you'll see not only the kinds of things that static tools find, like encryption algorithms in the code and hard-coded passwords and things like that. We also find the kinds of things that dynamic tools find. So you'll see here things like there's an example here. So cross-site request forgery, we see here anti-clickjacking, parameter pollution. Those kinds of problems are typically detected by analyzing HTTP. So notice that we're looking at this application multiple different ways. Contrast looks at every line of code to find the kinds of things that are easy to find and accurate to find that way. Contrast also looks at all the HTTP traffic to find things that are visible there. And we do a number of other kinds of analysis. We analyze all the configuration files. So you can see configuration problems like here's an overly long session timeout. You'll see JSPs in the wrong directory, things like that. And then the last thing we do is what we call runtime analysis. This is where we're actually tracking the data and control flow through the application itself. And this is uniquely effective at finding problems like SQL injection and cross-site scripting and so on. So we're really using multiple different analysis techniques, all contained within the single, simple to deploy agent. That's how we're getting great coverage over vulnerabilities and providing really accurate results.
Those scoring, those estimate scorings, medium, high, critical,
Yeah.
and so on, are those in some sense context free? Like, do you set those up separately based on your team's judgment, or is it possible for someone to go in and maybe tune them to a particular application?
It's a great question. And that comes up quite a bit, actually. Most organizations like to tune their risks to their business. We have sort of what we think of as centralized policy management across your entire application portfolio. So I can go in here and I can set the severity and likelihood for all the different assess rules. I can also set them for the protect rules that we'll talk about in a second. But that's all configurable because we think people should be able to control that. And in some
Yeah.
cases, we actually take into account the details of the vulnerability itself because not every SQL injection is the same. And so, sometimes we can adjust those factors based on what we actually see in the running application.
Yeah, my experience with tools that provide prejudged intensity levels for certain types of problems is that when you're doing the readout with audit or with whomever you're doing a readout with, invariably you're going through going, well, it says high, but it's really not, and
Yes.
ignore these three mediums because that's not right, and it makes the whole report just look terrible because all you're doing is crossing out all the highs and mediums before you know it. It feels like the tool just wasn't um, fit in or tailored to your environment at all. So it's good that you're doing that. That strikes me as a pretty important policy management function.
Yeah, and I'm not going to say we've solved that problem 100%, right? There are going to be things that we don't know about an application that a development team or even an audit team might know about the context of that app or things like that. But I will say that's the whole principle behind Contrast, is that we can do a much better job of assessing risk from inside the application itself. That's where we can find the absolute most amount of context about what's really going on to make really smart decisions about what is a vulnerability, what is an attack, and the severity of those things.
Yep, makes sense.
So let's do this. I want to show you just how real-time and continuous Contrast is. So I'm going to go in here. I'm going to delete the SQL injection vulnerabilities that we've already found here. Now, you'd be crazy to do this with most other tools because it takes so long to get really good results. But with Contrast, everything is real-time and continuous. So just like one of those cooking shows, I have WebGoat running here with Contrast enabled. And all you have to do to use Contrast is just browse around and fill out forms, click on links. It could be automated tests. It could be a Selenium script. It doesn't matter. Just exercise that application. And by the way, a number of the checks happen automatically when the application starts up. And some others you use the application to exercise. So here, I'll go to the string SQL injection lesson. And this is a very simple SQL injection flaw in WebGoat. And you don't have to exercise this. I can just put in Amoroso here and hit go. And in the time it took for that to return, Contrast analyzed this, found a vulnerability, and reported via Slack. In this case, it alerted me to a new critical vulnerability. Now, this is a real-time technology. And when I go check out the details of this vulnerability, you're going to see probably the most detailed vulnerability description that you've ever seen. In this case, we get a great title, which is actually pretty important, I think, because communicating these vulnerabilities is actually a big part of the problem. We want developers to read this and take action. So here we see, we get a great title. We start a timeline for this vulnerability. We can actually enforce SLAs around this vulnerability. So you can say, hey, this is a critical. We need to fix it in 30 days. You can say highs or 60 days or whatever. And then we see the details of the vulnerability itself. So here we can see sort of like a dynamic tool, we can see the details of the HTTP request, and here's the untrusted parameter that caused the problem. You can see that data was accessed on this line of code, so like a static tool, we show you exactly where in the code the problem is. And we show you the database query where this problem manifested itself. And if you think about SQL injection, it really is this data flowed through this code and landed in this SQL query without having been properly escaped or parameterized in a way that would have prevented SQL injection. And that's exactly what Contrast verified. If those defenses had been in place, we wouldn't have reported this problem and you wouldn't see it. So the reason... Oh, go ahead.
Going back earlier, don't change the screen, but earlier you deleted to do this demo.
Yeah.
And I'm wondering, what does that even mean to delete something? And is it possible for somebody to like, should I be worried about some mischief going on with the development team if they're deleting some of these vulnerabilities?
Yeah, it's interesting. So we have full role-based access control around all those kinds of abilities, of course. But our model is that, folks should be continuously rediscovering vulnerabilities all the time. It shouldn't be something that happens, once a year or once every 6 months at the big pen test time, right? We're reporting them continuously. So you can use Contrast the way that I did by, deleting the vulnerability, sort of starting clean and getting a full retest. I would actually prefer that people used it continuously. You should, if you think you've fixed this vulnerability, you should go in here and mark it as remediated. And then this vulnerability is now, we'll track it, we'll keep tabs on it. But if we discover it again, then we'll reopen it and you'll get a real continuous timeline so you can really see what's going on with regard to security.
Yeah, it's really, these are powerful capabilities. I like the idea of having some sort of RBAC in there because as a development manager, you presumably you trust your developers, but you never know, right? I mean, you'd want to make sure that there's nobody in sort of gaming the contrast system to mask vulnerabilities by deleting things and somehow suppressing reports on a maybe intentionally injected vulnerability.
That's right. And development teams are fantastic at what they do, but they are under a lot of pressure. They've got to deliver a lot of code fast, and I've seen some that have done some questionable things, like sort of code amnesty weekend, where you can just check in whatever you want, and all kinds of things.
Mm-hmm.
So that's why we think it's important to have sort of multiple slices at the apple. You find them in dev, you find them in QA and test and staging. There's a lot of ways to consume this.
Yep, makes sense.
And while we're on the subject, our model, by the way, is to provide developers this vulnerability information through the tools they're already using. So we've got plugins for Slack and HipChat and Eclipse and Visual Studio. We've got plugins for Jira and Jenkins and all the different tools that folks use to build software. We want them to consume it through that rather than have to go to some other dashboard.
Yeah, makes sense. So you want to be embedded. You want to embed right into the SDLC.
Exactly. So let's just take a quick peek at some of the other kinds of vulnerabilities that we found here. I'll zoom in on a couple things. You'll notice that some of these say, anti-caching controls missing on 3 pages. Well, what we're trying to do there is sort of roll up findings that typically you'll fix in one place. Rather than have 3 separate vulnerabilities for this, this is probably really one finding that folks can go put in a cache control in like their standard header or something, and they don't have to fix 3 separate vulnerabilities. So why report 3 separate ones? Another thing I wanted to point out here was our cross-site request forgery rule. This has been a very difficult. Where'd that go? Oh, there it is. This has been a very difficult vulnerability for people to reliably report because cross-site request forgery isn't always visible in the source code or in the HTTP traffic or in the backend connections. It's actually a combination of all 3 of those things that you need to look at to find CSRF reliably. So here you can see we can view the details here, and you can see on this page there was a state changing transaction, and we include the details here that wasn't protected by a token and a token check. So in order to discover that this was a non-idempotent transaction, we had to actually analyze the way the application actually runs, and so that's sort of our unique capability here. Okay, one last thing I wanted to show you about the vulnerability. This is our second piece, right? We looked at inventory, we're looking at vulnerability analysis now, and then we'll look at attacks in just a second. I wanted to show you our live application architecture diagram. And we generate one of these for every application. And it's incredibly useful for activities like threat modeling and security architecture review. This is generated by watching the actual application run. And what you'll see here is the browser technologies that are in use in this application. You'll see sort of the controller layer coming in here. We're using Spring. It goes into a number of technologies in the service layer. Normally, this would show things like JCE and logging libraries and things like that. And then on the back end, all the real database connections, also other backend connections, things like MQ and Active Directory and socket connections and web services is incredibly important.
Where you show a bidirectional arrow, does that mean calls in either direction or a call followed by data transfer?
Yeah, this is more about data flow. So what we're seeing is data flowing into the database and then results also coming back into the application. And the idea here is that this represents ground truth because we're measuring it directly from the running application. And invariably, when we talk to development teams and we show them their diagram, they're like, hey, wait a minute, I didn't know about that connection. And it's going, maybe it's going out to the internet or it's doing something they didn't understand. And you can drill down and see exactly what's going on under the hood, with each of these connections. In this case, it's just in-memory database, but often it's something that's much more interesting from a security perspective.
I see.
Yeah. So this is a nice capability, and it's something that we're building on and expanding on because I think it's important to get to those architectural level risks. All right. So any other questions on our vulnerability analysis capability?
No, let's proceed. This is interesting.
Okay. The key here, I think, is that we've tried to make vulnerability analysis easy and scalable for normal development teams so that you can do it across your whole application portfolio in parallel, as opposed to having to go sort of one app at a time and plod through. Oh, you might be interested in this. We were just approached by a company that in the wake of Equifax, they wanted to test all of their applications, and they were thinking about doing a pen test on them. But they had, just south of 1,000 applications that they wanted to do. So we did some quick math, and we were like, well, that's going to take a team of 20 about 2 years to get through. And they said, well, no, we have to be finished in 60 days. And we said, well, there's no way you're going to be able to pen test that fast. It's not possible. So what we'd like to do is come in and add our contrast agent to your environments. We think we can do that in less than a month. And we'll get real-time results very quickly off of all those applications. So we think we can have good results in a month, and we can also help you protect those applications almost immediately, rather than going back and then starting the process of, remediating all those vulnerabilities. Now we can actually help them protect their applications.
It also strikes me, I'm glad you took that path of embedding the agents and doing the work, because what you're doing here strikes me, tell me if I'm reading this correctly, as considerably more complete than an ad hoc pen test, right? Pen tests are only as good as the human being on the other end of it. They can miss, 90% of the problems. Well, typically a pen test stops when you find something juicy. Does that make sense to you? That's one of the great problems of pen testing. It's awesome if your goal is, hey, you got to find me some problems here because these managers won't listen. I need a few real demonstrable problems. There is nothing better on the planet than a scary pen test that spits out something that just looks awful. But what I've found is pen tests are not so good at giving you some warm and fuzzy that you found just about everything. Because like I said, usually a pen tester, once you found a couple of juicy ones, you're done.
Yeah, well, that's a sign of a relatively immature pen test, I think. Ultimately, what you're trying to get out of a pen test is some assurance that that application is secure enough. You can't just, do a pen test and then say, oh, well, we're good. So I spent, almost 15 years doing pen tests and code reviews and so on. And my thinking here is that you need automation like contrast in order to give you that broad coverage over the vast majority of vulnerabilities in an accurate way. That'll get you a long way down the road. And then your pen testers can actually focus on interesting, hard things. Like there's a lot of custom authentication schemes out there and crazy access control models and weird encryption stuff that actually deserves human attention from expert folks. But currently, as a nation, we're wasting our precious pen test resources chasing after things like cross-site scripting and SQL injection and things that are really not very interesting from a technical point of view.
Yep, agree.
Yeah. All right, so let's take a look at some attacks here. Contrast, in addition to finding vulnerabilities, also can identify and block attacks. And it's the same agent, it's the same technology. Actually, if I go to this servers tab, you can see for each server, you can configure it into a zone and so it might be in dev or prod or QA, and then you can also decide whether to turn on assess or protect in each of those zones. And the protect product, its goal is to identify attacks and block them. So what we found is that most organizations don't have good visibility into what's going on at the application layer from attack perspective. IDSs and WAFs and firewalls and things like that are okay at watching network traffic, but they're actually not very good at understanding what's going on at the application layer itself. So here we see just the attacks from a few minutes ago. It's our live view. I'm going to zoom out here and just show, say, the last month of attacks. And you can see Contrast has seen quite a number of different attackers targeting, using a number of different attack vectors and targeting these applications in my portfolio. And we can filter down on these a little bit. So I could choose, I want to see, hey, what's this attacker doing, and see, sort of exactly what they're targeting this Inertix application. They can look at this other one and see what they're targeting, and so on. You can also zoom in on a particular kind of attack, like I want to understand SQL injection, or I want to understand what's going on with WebGoat, and you can drill down very quickly into the data and get a good sense of what's going on. Now, the first major difference between what we do and with something like a WAF would do is that Contrast works from inside the running application. So we have much better context about attacks. I want you to think about a WAF for a second, sitting in front of an application. And I guess this applies to WAF or NG-WAF or any of the things that just look at network traffic. All they can see is the HTTP request. And they have to look at it and decide whether it's a real attack. And that request might have complicated data in it, right? It might have a JSON payload in it. It might have XML in there. It might have a serialized object in there. And there's just no way for a perimeter device to look at that HTTP request and decide whether it's a legitimate attack or not. So what they tend to do is they tend to guess. And they say, well, this has a single quote and equal sign and the word select in it. So I'm going to say that's a SQL injection attack, and they have to block it. And the problem with that is they're blocking too early. They make a lot of mistakes, and that means you end up having to use expensive human expert resources to tailor the WAF, to tune the rule set constantly. As your applications change, you have to tune the rules to make it work with the application.
As you're running this and trying to detect attacks and improve applications, would you generally prefer that the WAF be turned off? Because a WAF could potentially mask some things that you guys would see and that you could protect maybe a little more effectively. Does that make sense?
Yeah, absolutely. Most people don't run WAFs in blocking mode anyway, so it doesn't affect how Contrast works. And
sometimes like an IPS might have WAF-like capability that can mask some things. Right?
Yeah, that's an interesting question. I think, I guess I don't really care too much about what the IPS does. It might be breaking the application, but if you're investing the resources to tune it and make sure it doesn't break applications, then it doesn't hurt anything from our perspective, but it will miss a lot. And so, you shouldn't think that you're protected just because you've got a WAF or an IPS in place. They don't have the data. They don't have the visibility to block a lot of different kinds of attacks.
Got it.
So when Contrast looks at an attack, we're looking at it as it comes into the application, and the data flows to various places within the application. We're tracking things that look like potential attacks, but we track them until we're sure. So I'll give you a SQL injection example, but it's the same for these other kinds of flaws. Contrast tracks the data through the application, and if that data lands in a SQL query and modifies the meaning of that SQL query, that's when Contrast intervenes and blocks the attack. So that's something that a WAF can't do, right? A WAF can't see the SQL query as it's been fully formed within the application, and it doesn't know what part of the attacker's data landed in the query. It doesn't know how the structure of the query changed. It just can't see that stuff. And so Contrast's approach here is much more effective, much more accurate, and you can drop Contrast into an application and put it in blocking mode and be fine, because we only block things that are sort of confirmed real attacks. So let me filter out. So I'm going to show the things that we call probes. those are attacks that would have been blocked by a WAF, but really weren't attacks. They never hit their corresponding vulnerability. So I can filter those out. They're interesting because they tell you, hey, somebody's probably scanning you or someone's, banging around, but they're really not that dangerous. When I filter those out, I can zoom in on things that are a little more dangerous. These attacks are actually targeting a real vulnerability. And if I drill into the SQL injection flaws here, we can see some of the details. So you can see here these are a number of different probes here, and then so hopefully some of these I'll switch to filter just to the blocked ones here. I'll show.
What does probed mean again?
Yeah, so probed means that this potential attack, it looks like an attack, but it never hit the corresponding vulnerability.
Oh, I see.
So it's just like if you throw a rock at a brick wall.
Exploited means it worked.
Yeah, exploited is only comes up if you're in log mode. And then, of course, we have to let the vulnerability be exploited. Most of these are blocked. And when we zoom in and look at the details of a blocked attack, you can see here we show the HTTP request. We show the encoded attack here. And then that data flowed through the application and landed in this SQL query, obviously changing the meaning of the query, and Contrast blocked it. Now, interestingly, we have the full details here. We've got the exact line of code, the full stack trace, the full query here, and of course we report the full HTTP request. So in some ways we're providing the same data for attacks that we're providing for vulnerabilities, and we paint sort of the whole picture of what's going on with this application. Make sense?
No, it sure does. That's cool.
Let's take a look at one here. I'll switch over to WebGoat again, and this time we can exploit this with a simple SQL injection exploit. In this case, you can see that the attack was blocked, even though that WebGoat shows you the actual query that would have been sent to the database, and it clearly shows the injection worked. But and if it had worked, this would have dumped out all the credit card numbers. But Contrast intervened and blocked that request. Yeah. So any questions on our sort of basic attack blocking?
No, I think that's pretty powerful. I mean, when 0 days pop up,
Yeah.
how quickly can you get new capabilities embedded into a deployment? If I'm using the capability and it's running and I'm cool, and then all of a sudden there's some threat intelligence on some new issues in Python or Java or whatever. What do you do? Like, are there updates, patches? How do you get that new intelligence into the tool for your customer?
The short answer is that Contrast automatically updates all that stuff. But let me give you a little bit of the longer answer in the context of Equifax. So the week that, the day that the disclosure was made back in March about the Equifax vulnerability, Contrast, we didn't have protection for that particular vulnerability. So we quickly put out what we call a CVE shield. And it took us, I think it was less than a day, and we put out our CVE shield.
The struts problem?
Yeah, this is for the struts 2 vulnerability. It was an expression language injection problem.
Right.
And so all our customers were protected within a day, and everything sort of automatically updates. So we push it out, it goes out to all the agents, and the agents start enforcing that new rule. But interestingly, later in September, the actual is the week that Equifax disclosed their breach, there were 4 more vulnerabilities released in Struts 2. Not a really good week for that. But some of them were really serious, and Contrast already protected against those with our basic rules. So one of them was a Java deserialization flaw, and Contrast has a rule for all deserialization vulnerabilities. So we didn't have to do anything. In effect, our customers were protected, sort of a year and a half in advance of the 0 day, because they were already protected against this vulnerability that nobody knew anything about. So, our goal is to really change the game with response to novel vulnerabilities. we know customers have to be protected within a matter of hours after a new vulnerability is disclosed, because that's when the attacks happen. In fact, we saw widespread attacks across both Contrast and all of our customers within a few hours of the disclosure of the original Struts 2 problem. And like I said, we pushed out a CVE shield and everyone was protected very quickly. So, our customers were solid.
That's great.
It's making me crazy. So many organizations that I've talked to in the past month or so, when I talk to them about Equifax, they're like, oh, there's no way we could have responded faster than a few months to this problem, because people say there was a patch available, but really it was a replacement library. And it's not so easy to just go replace the framework in an application. It takes some engineering work. It's like replacing the engine in a car. There's going to be some engineering work to hook it up. And then you have to, of course, retest it, re-security test it, redeploy it. It takes a lot of time. So, with attacks starting right away, we can't have our applications being sitting ducks for several months. There's dozens of CVEs every week. So this has got to be a playbook that folks run all the time, and they got to be really good at this play.
Mm-hmm. It's powerful.
Yeah. So there's a few other things that I wanted to tell you about our protect capability. The first thing is that a lot of people ask about our performance, because operational performance is obviously critical. So Contrast is super, super fast because of the way that we work by instrumenting the application directly. We're sort of running at code speed. So on average, Contrast adds 50 microseconds to a round trip request. And that's for normal traffic. If you're under heavy attack, that number goes up to about 250 microseconds, or 251 millionths of a second. That's a quarter of a millisecond on a round trip request. Very, very fast, and hopefully is acceptable in most operational environments. But compared to like a WAF or something that requires an extra hop somewhere or separate parsing of an HTTP request, we are much, much faster than that, because we're sort of leveraging what the application has already done. Make sense?
Yeah, it does. I mean, at some point, you reach that, and those embedded applications where those numbers would be too big. But that's the vast minority of applications, especially if you're doing something SaaS. If you're enterprise using SaaS, then that level of performance issue is absolutely negligible. So that's good news.
Yeah, that's right. And because Contrast is sort of part of the application, it works well in cloud environments where you've got a bunch of APIs stood up. We are uniquely good at protecting APIs. WAFs have a hard time protecting APIs because the protocols are so complicated. It's difficult for them to tell whether something's a real attack or just normal traffic. And so for us, inside the application, it looks a lot like other kinds of applications, right? Inside the API, because it's just processing a request.
Let me ask a question, because we are talking now about active mitigation and the tool really becoming part of the runtime execution. If there is a problem, let's say there's an outage and some serious problem, and the team's doing root cause analysis. I'm sure a lot of people listening to this spend half their time on that. Right?
Yeah.
Problem, you're trying to make the case. Help me with how, as a developer, I sort of convince the other team members. Let's say I'm the proponent of using Contrast. Perhaps I bought it, I brought it in, it's my baby, I like it, I use it, and then there's an outage. You know how that works. You're a developer. There'd be a lot of people who maybe never heard of Contrast and say, hey, that's the thing that's causing the problem. Get rid of that thing. That's a variable we don't need. What happens in those kind of environments? Like, how can you help a developer stand their ground and demonstrate that that you know what I mean?
Yeah, absolutely. It's a fair question. So one of the things that we believe with Contrast is that you should deploy it in your development process, right? Contrast should live with your application as part of dev and as part of your test and staging environments, and then you promote into production exactly what you built and tested. So there's much less risk of this, like some new operational thing being introduced in production, because Contrast is there. It's part of your application from the time it was born, and it's part of all the testing. So that's, as a developer, that would give me a lot of confidence. Like, it's not Contrast that broke it because we tested with Contrast. The other thing is the way that Contrast works is relatively low interference with applications. We've been working with security instrumentation now since 2009, and we've got 10,000 applications out there that we're currently continuously monitoring and protecting. We've got a lot of miles on this instrumentation engine, and we've built it in a way that it doesn't interfere with operational aspects of applications. So, it really Contrast, I think of it as like any other library, like a part of an application. And so, you're probably using hundreds of open source libraries in your applications. Think of Contrast just like any one of those. It just happens to be the thing that protects against attacks.
No, I think that's a good answer.
The other piece for a developer, the piece that I like about Contrast is that it solves a ton of the work of remediating vulnerabilities. I know hundreds of organizations that have large databases full of vulnerabilities. They call it a risk register, they call it their vulnerability management system, however they track those. They've got a huge database of those that are taking years to get fixed because it's a ton of work. Contrast can come in and give this, sort of different way of remediating these vulnerabilities instantly across a whole portfolio of applications. So you could wipe out most of your security debt instantly across your organization and protect applications that have been vulnerable for years. I think it's an important part of your AppSec strategy is you need to prioritize what you work on, and Contrast can help change the math there. You can protect all of your applications against SQL injection in relatively short order, and then focus on other harder problems that maybe demand a little more creativity.
Yep, that sounds good.
All right, well, so let's zoom out a little bit and talk about, big picture. How does Contrast change the game? For me, organizations that have lots of applications are in a really difficult situation. They've got to be able to respond instantly to new threats. They've got tons of new code being developed at all-time rates of speed, and they don't have the manpower to deal with that level of work. And so Contrast in that way is sort of a force multiplier. How do you see that problem?
I think you just described it well. I mean, there's a combinatorial explosion of code that people have to deal with once you start, expanding your business outside the enterprise. One casualty of the perimeter dissolution is that now we have kids in a candy store in terms of the kinds of applications and systems that are out there for use. There are good ones and there are bad ones, but yeah, I mean, it really does introduce a whole new dimension. You and I have talked before. I really do believe, kind of from a big picture perspective, that application security has become the long pole in the tent. It's why I spend a lot of time with people like yourself and in your industry, your segment of the industry, trying to understand how to fix this. Because show me a company that just had a gigantic problem, and I'll show you a company that probably had an AppSec issue. I mean, that's just been the empirical observation. I don't think anybody disagrees with that right now. It's almost never a network jailbreak or something. You know what I mean? That's not what it's been. Different years ago. Now it's applications are all over the place. They define the business. There's a lot of code out there. There's non-homogeneity. There's not even consistency amongst the different development teams that are doing the work. So I think what's going to happen is the kinds of things that you and your team are building are going to have to become more standard, more uniform. Like one thing I'd like to see, maybe this will be some R&D for you and your team, is the degree to which you guys can exist in an ecosystem with WAFs and IPSs and so on. Maybe there are some standard protocol interactions between the different components that might help, and maybe you've got some of that now. But yeah, big picture, I think you describe it accurately, and I think companies and CISO teams that don't come up with some sort of a solution for their application risk, they're walking a tightrope in my estimation.
Are you more of a code hygiene kind of person or an operational defense kind of person?
Well, you would like to think that, I don't know that hygiene would be right, but the simplicity and elegance and doing the code properly, you'd like to think that at some point that would supplant the need, but I don't think we're certainly not there now. We may never be there, but yeah, you kind of want to do both, right? I mean, if I'm sick, then I want to be able to see it and fix it. It'd be nice to try and prevent that sickness. I'd asked you earlier about size of code. I think when you do see monster size code, 20 million lines of code, that to me is a symptom that something is probably wrong. I don't know that I can just put my finger on it, but you're as good a developer as anybody I know. There is a lot of bad coding out there, and you're never going to get away from the need to have harnesses, real-time harnesses that sit and provide scaffolded protection around what's going on and blocking and stopping. You guys are going to sell a lot of platforms, but I think you'd also agree that anything we can do to improve the software process, improve the training of developers, improve the maturity levels of teams is good, right? There's nothing you're doing here that's inconsistent with that. Like if I want to have a more mature process, you guys are probably cheering right along saying, yeah, absolutely. You don't want to ever have bad coding in any context. So I think they all work together. Does that make sense?
I'd say I was a code hygiene kind of person. I grew up in the
all
mainframe days.
Yeah,
where we used to do line by line code review on fanfold paper with a team of folks, and so I kind of grew up with a level of rigor that a lot of folks really haven't. But after sort of 20 years of working in security and focusing on that aspect of the problem, I'm starting to get concerned that we're never going to actually be able to reliably produce secure code. So that means that you're going to have protection.
They don't write code anymore. They piece things together, right? And that's been my observation.
A lot of people say that. I mean, that's like marketing from the the repository companies, that it's now all about assembly. But the fact is, people do use a lot of libraries, but at the end of the day, they're building business logic that's custom to them, and the interesting code is all being custom written. And that number hasn't really changed very much. The top of the iceberg is basically the same. The bottom has gotten bigger and bigger and bigger over the years, but the amount of, business logic has not really dramatically changed. It's still, most apps have, between 100,000 and 1 million lines of custom code. And then there's, a ton of libraries supporting that.
Yeah, I think that's right. And you're right, the business logic does differentiate and provide that is the localization, that's the logic that programmers are following. Well, let's keep our fingers crossed. I'd like to see, more and more development teams using platforms like yours. I can't see any downside. And yeah, I hope people get better at training programmers and following more disciplined process. Both of them would be good.
Well, that's our vision, is we want to support the entire software development lifecycle, not just blocking attacks, because then, frankly, you never get better at writing code. And we can't just support writing better code because there's a critical need for blocking attacks, especially in the situation you pointed out, the novel attacks. So we're trying to provide a complete solution for AppSec.
It's great. Very exciting work.